Hello everyone, welcome to Chemistry EduHub channel. Today we are going to talk about the coordinate covalent bond, which is also called a dative bond. Now what is this bond? It is a special type of bond of covalent bond, Now what is the definition? A bond formed between two atoms, by sharing of pair of electrons contributed by one of the atoms. That means when the bond is formed between two atoms, one of the atoms gives 2 electrons, the other one only takes those electrons, and these 2 electrons are shared between the two atoms. One is contributing 2, the other is contributing 0. That is the meaning of coordinate covalent bond. This bond is represented by an arrow from the donor atom to the acceptor atom. Donor is which donates electrons, acceptor is which accepts electrons. Let us understand the coordinate covalent bond in few examples. The best example is between ammonia and boron trifluoride. Nitrogen has a lone pair and the central atom of boron trifluoride is boron, where the boron will have vacant orbital. So you see, nitrogen having the lone pair, boron having the empty orbital. So this electron pair will be donated to the boron. So hence, the bond is formed this way from nitrogen to boron trifluoride. Now nitrogen alone is giving 2 electrons, boron is giving 0 electrons, but both of them will share 1 electron each. Such bond is called a dative bond. Similarly, you can see between water, where water has 2 lone pairs and the hydrogen H plus has vacant orbital. So this electron pair will be given to H plus. So you see the bond formed between water and H plus, and this is the formation of H3O plus hydronium ion. The same way you can see between ammonia and hydrogen plus, this way. So ammonium ion forming bond with forming bond with H plus and forms NH4 plus called ammonium ion. And the properties of these coordinate covalent compounds will be similar to covalent compounds only. Now let us understand the metallic bonding. So metallic bond, by the name itself, we can understand that it is a bond formed between metals, between metal atoms. So what are the general properties of metals? Metals are all crystalline solids, or you can say they are solids. But there is an exception. Except mercury being a liquid, rest all are solids. They have high melting and boiling points because they have a strong metallic bond. Their melting and boiling points are very much high. And they are good conductors of electricity because of the free ions or free electrons. Because of the presence of free ions or electrons. Now let us understand the metallic bonding with the help of electron C model. According to electron C model or free electron theory, metal atoms release or liberate electrons. Which electrons? Valence electrons into the crystal. So as they release electrons into the crystal, they form positively charged particles as well as negatively charged electrons. These are the metal cations without valence electrons, and in between you can see the free electrons moving throughout the crystal. Now if this is the crystal lattice, these are the free electrons, or you can say delocalized electrons. That means they can move freely from one end to the other end. Now what is this positive part? They are called kernels. The positive part of the metal, that is, if this is the nucleus of the metal, the innermost electrons except the valence electrons are nucleus with the innermost electrons, nucleus plus inner shell electrons. Together it is called kernel, except for the valence electrons, because valence electrons are moving freely outside the inside the crystal, which is outside the atom. Now because of this, the metal atoms attain positive charge, metal gets the positive charge, and the electrons are anyways negative, and these electrons which are moving freely, they form a pool of electrons, or you can say a sea of electrons. This is the representation of a metallic bond in the given metal. So the cations are considered to be in the fixed position. They do not move, but the electrons will move from one part to the other, which are delocalized. And because of the presence of free electrons, the metals are good conductors of both heat and electricity. This is the reason why we use only metals in the electric wires or for any kind of conduction. The main drawback of this theory is different metals have different properties. Different metals have different properties. So why different metals have different properties was not explained by this model. This is the only drawback of this model.